In this video, I'm going to look at home loan repayments, and specifically my focus will be on how do you set out your work to ensure you receive full marks in the HSC. So the focus will be on notation and setting out rather than deriving a formula or getting a final answer. So let's have a look at this example. Frank has a $560,000 loan which needs to be paid off in 30 years. If the loan charges interest of 6% per annum compounded monthly, what is Frank's monthly repayments? So let's write a summary of what's been given in the question. We have our principal, our borrowing of $560,000. We have a rate of 0.06 per year, but because everything's compounded monthly, I need to convert that to a monthly rate, which ends up being 0.5%. So that would be 0.05. So essentially what we did was 6 divided by 12, and then we need to divide it by 100 because we need that answer as a decimal. So that's our rate, and our number of payments is 30 years, but again, we need to convert that to monthly, so we need to multiply that by 12, so that would be 360 months. What we are after is the monthly repayments, and we will use the pronumeral M for repayments. So how we go about answering these questions is by establishing a pattern. You can't just jump in and use a geometric series sum formula. You need to actually establish a pattern. Usually questions are set up where part 1 actually gets you to establish that pattern, and then part 2 asks you to work out the repayment. So the way to go about it is 1 month at a time. So A1 is how much is our loan at the end of the first month. So our borrowing accumulates interest for 1 month. So we use our compound interest formula. So 1 plus R to the power of 1 because it's 1 month. So at the end of the month, we owe the bank this much, and then we make our first repayment. So the total amount after interest and repayment is given by this. Then interest is calculated again, but this time around for the second month, what's happening is if I draw a timeline, we had our $560,000 right at the beginning, right at the start, 0. After 1 month, our loan is A1. It's no longer 560. So when we come to calculate interest for the second month here, we are calculating interest on A1. So our principal now is A1. It's no longer 560,000. So A1 accumulates interest for 1 month. So compound interest, and we make our next repayment. Now I am going to substitute in for A1 all of this. Now this needs to be done in the exam as part of your solution. So $560,000, 1.005 minus M, that's all A1. That gets multiplied by 1.005 minus M. Then I'm going to expand the square brackets. So multiply the 1.005 here by every term inside the brackets. So that gives me 560,000, 1.005 squared minus M times 1.005 minus M. And now I'm going to take a factor of minus M out of these two terms. So I'm going to leave my first term alone, 560,000, outside of 1.005 squared minus m. And then I'm actually going to write my factorization the other way, 1 plus 1.005. That's A2. Now, to work out A3, I am now going to work out the interest on A2 for 1 month. So my new principal is A2. So A3 is A2. Accumulate interest for 1 month, 1.005 to the power of 1, and minus my next repayment. Again, I am going to substitute all of these in for A2. A bit tedious, but as I said, we need to establish a pattern. So that would be 560,000, 1.005 squared minus m, 1 plus 1.005. And all of this gets multiplied by 1.005 to the power of 1 minus m. Again, I am going to multiply this by the two terms inside the brackets. So my first term becomes 560,000, 1.005 cubed minus m, 1.005 plus 1.005 squared, and then minus m at the end. And next step is again to factorize this minus m out. So the first term stays the same. If I take a factor of m out, I end up with 1 plus 1.005 plus 1.005 squared. And I can see I've made a mistake in my notation above. Let's just correct that. This squared should be on the inside here. Okay, so hopefully I've established a pattern here. You can see for A3, I have 3 here, and I have a compound interest formula with a power of 3. I have minus m, and then I have a pattern of a geometric series here. So that's enough for establishing the pattern. I can then put 3 dots and write, therefore, A360 will be 560,000, 1.005 to the power of 360 minus m, and our pattern is 1 plus 1.005 plus squared plus, and the last term is 1 less, so 1.005 to the power of 359. I then need to write that this is a geometric progression with, I need 3 values: my initial value, my ratio, and the number of terms. Now the number of terms is actually 360 because I have 1 here, and then we have 359 terms of 1.005. Therefore, my A360 is 560,000, 1.005 to 360 minus m, and now I use my geometric series sum equation. A, which is 1, r to the n, that's 1.005 to 360 minus 1, over r minus 1, which gives me 0.005. Now, how much is A360? Well, at the end of the loan, I should owe the bank nothing. So A360 is equal to 0. So that would result in rearranging M equaling 560,000, 1.005 to the power of 360 divided by my series, sum of the series. Now, if I put that in the calculator and make an error, if I've shown all my working, there is a high degree of likelihood that I get full marks for my question. Maybe if I'm unlucky, I might lose 1 mark. The answer for this question on the calculator would be $3,357.48. So for this type of question, it's essential to establish a pattern using 3 terms and then using that pattern providing the final answer. Now, my question actually has a second part. If a Frank can only afford repayments of 3,000 per month, what is his borrowing power? So what's the maximum loan that they would give him, given that he can only afford 3,000? So assuming everything else is the same, and this is the second part of the question, I don't have to go and redo everything. I got to the point of A360 equaling the principal, which now I don't know what it is, outside of 1.005 to the power of 360 minus, but now I know my repayments are going to be 3,000. And my sum of the series was so again, A360 has to be 0. So I can rearrange. Let's write that. A360 equals 0. Rearrange making P the subject. So P would be 3,000, 1.005 to the power of 360 minus 1 all over 0.005 divided by 1.005 to the power of 360. And when we work that out, we get $500,374.84. So as I said, the purpose of this example is to highlight the correct setting out to ensure full marks in the HSC. The questions are rarely this straightforward. Usually they have a twist in it. For example, the interest rate might change or the person might make a lump sum. If the question has 2 different time periods, then you treat them as 2 separate questions, and the first part feeds in the second part. But that's the process for answering this type of question.